I'd like to thank everyone for joining us this evening. This is our October Berks Astronomy Club meeting. And we have a couple things coming up. We'll address upcoming events and things like that after this. But with that, we'll hand it over to Vice President Dave Brown.
Thank you, Lon. My wife and I always enjoy watching WFMZ 69 News. We have for years. And I noticed recently there was this new meteorologist that came on board. And almost every time he gave a weather forecast, he included something about astronomy, what's to see in the sky, pictures of the moon, things like that. So I reached out to him, emailed him at the studio, and invited him to come and look through our telescope sometime. And we exchanged phone numbers, and a few texts later, he offered to do a program for us on space weather. So that's why he is here this evening. So please give a warm welcome to Drew Anderson from WFMZ Meteorologist.
Well, thank you so much for that introduction. I appreciate that.
You're welcome.
It's kind of weird to do the applause and the welcome over Zoom, but I think we're getting used to it at this point. So yeah, let's talk a little bit about space weather. I'll share my screen in just a second, just to take a step back in case you're not familiar. To be completely honest, I don't know why it's called space weather. I can see the parallels. So what we're talking about is, if you ever heard of geostorms, so geomagnetic storms, coronal mass ejections, all that sort of realm, solar flares, it's all in the same wheelhouse. And it's just that energy from the sun that moves across space and has the potential to disrupt technology here on Earth. And that gets the name space weather. So I thought we'd just talk and kind of delve into a little bit more of exactly what's happening with there and why it happens. And also recently it's been in the news because of NASA. And I did a little story about that. So I want to get things started before we kind of get into more of the material portion of it with the story, speaking of Channel 69, that I just did for the news. Instead of using the one that they have actually on the news where they introduce the story from the anchor perspective, I'm just going to go with the raw part. And, you know, this one's pretty stripped down. For an audience like you guys, I can get a little more technical. I can get a little more sciencey. I got to keep in mind when I'm doing something sciencey on television that most people don't have a sturdy science background. I think a lot of people are interested in science things, but I also feel science intimidates folks because they just don't feel like they're smart or understand science well. And for me, that's kind of helped shape my presentation for how I do weather, different things over the years. Going to school, right? They're pounding all that, the technical kind of knowledge into your head. And one of the things I had to learn over the last decade of doing the weather at different stations around Pennsylvania guy, I'm from Chester County. And what I learned is the more the technical science, the technical parts of it I can remove, the stronger the communication will be. So here's a great example. So a lot of people don't know that dew points, I like to say Drew points because my name's Drew. I mean, you know, we're punny in weather, can't help it. So dew points, they indicate how humid it feels outside. So the higher the dew point, the more humid it feels. Well, most people don't understand that dew point is an indicator of how humid it feels. Most people just assume it's relative humidity. So you'll see a lot of times on television, a lot of folks even here at FMZ will show dew points and say something like, hey, we got dew points in the 60s today, so that's why it feels so humid. But hey, take a look at these dew points in the 50s to our north. That's that cooler, drier air. That drier air is going to head down our way. Well, why say that when I can just say, yeah, it's still humid. It's really humid today, but tomorrow it's not going to be as humid. So kind of removing some of that, the technical part, the dew points. Again, I love dew points. I think it's interesting. I love to talk them all day. But I just don't feel for in terms of making my communication, my science message stick, that I need that. And it's funny because I'm like really sciencey on TV. I love explaining the hows and whys of different things. Like we were talking about, I love talking about what's up in the night sky. When I talk about Mars, of course, we got something big happening coming up on the 13th, as you guys know, with Mars. So I'll talk about that, give that a little shout out on the weekend. And so even though I'll get into that, I just never get technical. Like if, let's say, for example, I wanted to talk about that Dippin' Dots sort of snow pellets, I would explain what it is, but I've never say the name grapple. And it's just something I picked up over the years, partly from teaching, because I've been fortunate enough to teach at Penn State Lehigh Valley up here. I currently work at Westchester University teaching meteorology and earth science courses. You know, I can tell right away when I'm being a little too sciencey or I'm not connecting, right? I see the dozing off, or I see the eyes just glaze over. And so teaching kind of made me a little bit better on television in how to communicate. So with that in mind, let me show you my science story. And we get sciencey in it, but you'll see we're not going to get too technical. And this is just kind of a little story I did because NASA recently discovered that the sun's in a new phase. And for more on that, back over to you, Drew.
Here's a look at what I got to see during the total eclipse in 2017. See how there's that glow around the sun? That's energy leaving the sun. And it happens all the time.
And while there's always outflow from the sun, there are particular moments where the sun has an outburst.
And that gets called a solar flare, which is what Dan studies.
I can sit at my computer screen and watch a solar flare happen. And I just think like it's so tangible. It's really, really exciting for the sort of kid in me.
Dan's a scientist at NASA. He studies how to better forecast these big bursts of energy. See, solar flares, they have the potential to affect us on Earth.
And it can disrupt radio communication for airplanes. It can cause GPS inaccuracies. So there's actually a lot of effects we feel through our technological systems, and we have to be prepared for them.
So why haven't we heard about this before?
For the last few years, and the sun's been pretty quiet. We haven't seen a lot of big outbursts.
But all that is about to change. NASA has just discovered that the sun is entering a new phase, a phase where the sun will have a lot more of these solar flares than usual.
Going forward the next couple of years towards like 2024, 2025, these events are going to be a lot more common.
What if one of these big energy bursts is way, way bigger than usual?
That actually can damage wide-scale power grids and cause huge blackouts.
To find out how concerned we should be, I reached out to PPL, one of our local power companies.
We have not had any negative effects, any impacts on our grid in the past from these.
Joe's a communications manager at PPL, and he says their supercomputer smart grid technology is ready for solar flares.
Over the years, we've created new paths for power to get into areas. So if something happens on one line, we can switch that power and get into that community from another direction.
This new innovative technology has already showed its value. So far, it's prevented, get this, 1 million power outages. Time will tell if we get a real test by the sun.
You know, on Earth, it feels like we're pretty isolated from space, but we're not. And you can actually kind of almost feel like you can reach out and touch space.
With the Out of This World story from Lehigh County, I'm meteorologist Drew Anderson on 69 News.
Nice little introduction. We'll get into and kind of get more into some of the science behind it. But, some interesting stuff there. So you guys know if you've done some solar viewing, which I think is so cool. I just had an opportunity over the weekend to do that when I was over doing a story about the meteor shower that's coming up in 2 weeks. And I was just pre-filming it early. And there's a local NASA ambassador here, so I got to look through his telescope and do some solar viewing. And I was surprised. I didn't see any sunspots or anything. I mean, the sun, as you know, has been really quiet over the last couple of years. And now we're moving our way into that new phase, which is, if you're not familiar with, phases of the sun are kind of like our seasons, except instead of being a couple months, it's years. And you have where the sun's quiet, there's less sunspots, which means there's less energy that's leaving the sun. There's always energy leaving the sun, but there's less of these bigger bursts of energy leaving the sun. But then it goes into a part where there's kind of a maximum where there's a lot more sunspots. And in about 5 years or so, that's when it'll be happening. And at that point, why it should be very similar to what we had about the beginning of last decade, around, first couple of years of those decades, I think the sun was a lot more active. And it shouldn't be that big of a deal in terms of our technology here. There's always that potential that we could get some big bursts. There's some historical accounts that I don't remember what it was. It was somewhere in the 1800s that essentially the telegraphs went down. Back in the days of telegraphs for communications, and it's speculated that it was from a big burst of energy from the sun, probably one of these giant coronal mass ejections that just had a lot more energy than usual. So let's kind of get into all of that and just break it down a little bit more. And just a couple little basic things. So when I teach science, because it's just, it's teacher me, I like to assume the person with me knows nothing about science, because I feel I can take it from the ground up. So I know you guys are all into science, and I understand the atoms work. And essentially, in atoms, they're like the building blocks of what everything's made of. You got a positive part, you got a negative part. I look at it as like a magnet, right? The best way for me to think about it is, I wonder if there's anything. Oh, there's a plastic. All right, let me try to get this plastic bag here. This is an example of what to not do at work, but that's okay. One of the best examples, and I love using props. I think we got some old scripts in here. So your hair your hair loves giving off negative charges. So if you get something plastic and rub something plastic to your hair, plastic overall likes to carry a positive charge, but I'm kind of charging up. And my hair can tell a little bit sticking toward there. And essentially that's getting the negative charges to kind of go to, oh, I'm messing up my nice hair. It's getting the negative charges to go to the bottom of my hair. When my hair sticks up, those charges are kind of repelling on the other little ends of the hair. And then they're attracted to the bag because plastic overall kind of carries positive charge. So it's cool that there's all these different, I'm glad I'm putting that in the trash can. Play with my hair on that. It's really cool that stuff has these positive and negative charges. And when these things connect, that's how you can get lightning, all that sort of stuff. So that sort of stuff is always leaving the sun. And, this is actually kind of interesting. A lot of people don't understand that temperature, technically speaking, is not about is it hot or is it cold. Temperature measures how fast the air moves. Trash bag's falling down there. Temperature measures how fast the air moves. So a high temperature, i.e. hot for us, just means the air is moving really fast, whereas low temperature, the air is moving much slower. Whereas heat itself is from air running into you. When air runs into other air or air runs into you, those collisions that kind of impact the energy is what makes heat. And so just kind of with some of those basic things that in the background, I'm going to skip through just to kind of get some of the more cool stuff, how some of the energy is transferred and how that works in the sun. But essentially, we're going to skip right to kind of the outer atmosphere, really the outer core, I guess you could call it. Core is probably not great terminology. The outer zone of the sun. And what's really cool, and I hope maybe some of you got to also experience in 2017 the total eclipse. I was down in Tennessee, and kind of like when I saw Saturn through a telescope for the first time. Well, I almost hate to say this because it almost sounds cliche, but it was life changing. I mean that was one of the coolest things I've ever seen in my life. It was just so wow for so many reasons. How dark it got, but the noises changed. The lights came down on the valley below, came on. I got to see some stars or planets out. And it was really cool how the second a sliver of the sun came back, it kind of the light got right back to normal. But what's really cool during that eclipse is you can see the energy that's always leaving the sun. So at all times, and I think I got a picture of it. So this is actually a picture from the eclipse in 2017 down in Tennessee. It was an awesome experience. On the ridge, there was about 8 parking spaces. All of us were from a different state. And it was just basically these strangers all meeting together for a common purpose, and we all got talking. Someone was playing Dark Side of the Moon as we were waiting. And the guy next to me was a little bit of an amateur photographer, and he got that picture standing next to me. And we're seeing the corona. That's kind of the name for that energy. So that charged energy. It's got those kind of pluses and minuses with it that's leaving the sun. It's always there. The sun's always giving off energy, and I'm talking energy in 2 forms. Yeah, we know when we go outside, you feel the energy from the sun. It feels warm. I'm not necessarily talking about that. I'm also talking about this kind of the energy that the sun's giving off into space, these charged particles that just kind of go into space. And as they travel, it gets called solar wind, which we'll talk about in a second. So to kind of back up what we're talking about and what exactly that is, what that type of energy is that we just saw during that total eclipse leaving the sun. The sun is kind of interesting. And just to make it real simple, the sun's made up of helium and hydrogen. So it's just a hot ball of gas, right? And some of those gases, and gases are made of atoms. Atoms is like when I was just playing with the trash bag. Atoms are made of positive and negative charges. So some of those atoms, some of those gases, so gas is usually 2 atoms connected together, at least 2 atoms or more. They're flowing away from that outer edge of the sun and all times into space. And when a regular gas, like say, right, the gas in your balloon, like a helium in a balloon, when it has a charge to it, when it's not just like a regular gas, I mean, certainly it's a gas, just like a balloon, but there's more to it when it kind of has a charge to it, like maybe overall that gas is a negative charge, or overall maybe that gas is a positive charge. That gets that new terminology of plasma. It's just saying plasma is basically a type of gas, but it's different from regular gas because it has a little bit of a charge to it. And in the sun, there's a lot of collisions of these atoms, and like we were talking about earlier, heat is generated when, just to be basic, when stuff runs into other stuff, when atoms run into atoms, when atoms run into you, that's what creates heat. So there's a lot of collisions, and so a lot of heat's generated. Heat's going to have air move, the gas move fast. So part of the reasons there's so many collisions is those gases, those atoms there are moving so fast. When you have something moving so fast they slam into each other, that's going to have a pretty bigger impact. That collision is going to be much bigger, so more heat's going to be produced. And it makes sense, right? Think about if you're on I-78 and two tractor trailers are going 70 and they crash into each other. Imagine the same scenario in a Walmart parking lot where they're going 2 miles an hour. Not a big deal. So in the sun, you're always having these collisions. And as atoms collide, in some of these cases in the sun, some of those atoms will actually break apart. And when atoms break apart, that gives off energy. And that actually kind of has a little bit to do with how it works at a nuclear power plant. Kind of how they, it's actually really cool. I don't know if you're familiar with how it works at a nuclear power plant. But in short, it goes like this. There's uranium in a pool. And the whole reason of the uranium is to warm up the water in the pool to get some of that water to evaporate. Much like if you boil pasta water, you'll see, well, you can't see steam because technically speaking, steam is water vapor, which is the gas from water, and you can't see gas. But you'll see like a cloud. You'll see like some condensation above your pot of boiling water, and it evaporates. And if you felt the air, you'd feel the water vapor. You'd feel the, technically speaking, steam. Even though most people think steam's that kind of that if you make a tea, you see moisture or cloud coming off. So really, what it's designed to do at a nuclear power plant is to boil water, because when you boil water, it's going to heat it up. Some of it's going to evaporate. So you're switching water into air, gas. Well, the way our wind works, like the whole reason we have wind, and honestly, the whole reason we have weather is when you have more air in one spot and less air in another spot, you know what? Earth's not into that. So what happens is when you have more air or water in one spot, it flows to where there's less. So what they're doing in a nuclear power plant is they're boiling the water to make more air. So now they have more air in the spot, and it's going to flow to where there's less air. So essentially they're making wind. And they use that wind to spin turbines. And turbines are just, we'll call blades. Imagine like blades, like an engine of an airplane. And the wind gets those blades to spin. And because those blades spin, they're spinning I guess the best way to put it is, let's call it two magnets around, you got two strong magnets around some copper, and by having magnets go around other metals, that creates essential electricity. But the most efficient way that they figured out is, let's boil water to get more air in one spot, to essentially make wind, to use that wind to make our turbines spin, and that's what'll kind of get the electricity made. And then that hot air, that's right, you boil the water, that hot air, it goes through a system where it gets cooled down. They'll bring in some water and pipes that's cooler, and that hot air will run over those cooler pipes, and that hot air will condense. It'll cool down, and when it cools down to a certain temperature, or the dew point, you get the moisture in that hot air to come out as liquid water, and that just goes right back in the pool, and it's a closed cycle, and it's kind of cool. But getting back how I got on that tangent from this, is part of the way that uranium works is its collision of the uranium atoms inside. The collisions is what's generating that heat. That's what helps generate heat in the sun. And sometimes when you have these collisions, the atoms can break apart. And when atoms break apart, and that kind of leads to how it works a little bit in the sun. I always mix these two up. I think it's helium that it leads from that. Let me just check how it works in the sun. And I'll share my PowerPoint in case you guys want to go through how the energy and heat's created in the sun. But yeah, so sometimes the hydrogen atoms, when they stick together in the sun, that'll lead to creating helium atoms, and then also some of them break apart, and that also releases a lot of heat in the sun. But I think it's this one where I kind of talk about that. But that'll help them with uranium. Sometimes the atoms break apart, that always releases a lot of heat. So, all right, let's bring that back to the sun. Let's get back to what we're talking about there. So with the sun, we talked about how there's always energy leaving it, that corona, and what that is that's a gas with a charge to it. And because it has a charge, it doesn't get called a gas anymore, it gets called a plasma. And most of the sun is, oh, hang on, put on full screen to be silly. There we go, great. And it's really interesting to think about. You can just imagine that, right? We know how hot the sun is, just how intense those collisions are, and the atoms breaking apart. That most of the sun is plasma for that very reason. And I just think it's really cool that you can see that with the naked eye during a total eclipse. I mean, it's always there, but we don't usually get to see it. And I just think it's so neat to see that. And that energy then at that point, it travels through space. And if you have a lot more than usual, that can start leading to disruption. So we'll kind of get into when that more happens. And one of the key indicators of that, and you've probably seen it if you've done some solar viewing, not so much the last couple of years, but certainly, I don't know, like 5-7 years ago, it was a lot more active. You get these sunspots. And when you see a sunspot, it's actually an area where it's a little bit cooler compared to what's around it. So the sun's a lot of convection. Convection is just a fancy way of saying a lava lamp. It's just a fancy way of saying warm stuff rises, cool stuff sinks. Like a lava lamp. It's the way reason works. That oil, it gets warmed up by heat source, it rises. It's away from the heat source. It cools down it comes. Kind of the whole way we get thunderstorms, really. It's warm air rises, and then it cools off down there, and the cool air drops back down to Earth. But you need that warm rising air to fuel the storm. And a healthy thunderstorm has to have cold air drop out of it. Eventually, too much cold air comes out of a thunderstorm and it kills it. Essentially, it strangles the storm, if you will, because it prevents the warm air from entering. A thunderstorm is a lot like a car. In order for a car to work, you got to put fuel in it, which mine, I just got a notification on the way back to the station tonight that it needs some fuel. But if you have a tennis ball in the exhaust pipe, that's going to be a problem. You also need to have exhaust come out. And so a healthy thunderstorm needs that fuel and exhaust. But eventually, in these storms, both thunderstorms and tornadoes, there's too much exhaust. There's too much cold air coming out of the storm, and it stops the warmer air from rising, since cold air has got more muscle than warm air. So not only are the sunspots some areas that kind of a little cooler, they really, what they're indicating is that the sun is more active. It's creating a little bit more of this charged gas than usual. And it's setting that out more in space than usual. And also it's indicating that we have some areas of kind of more intense magnetic activity. And, I think of electricity itself as a core. Like right now, my laptop plugged in. I think of electricity as moving negative charges in a very simplistic view. So, and this is a really simplified, dare I say, dumbed down version kind of stuff that's going on with the sun. But to me, it helps visualize a little bit. You're going to have situations where the sun's sending a lot more negative charges out into space. Or electricity here on Earth, how the current essentially works, again, it's kind of lowering down the science a bit, it's just flowing negative charges. So it also makes sense if you get more of these negative charges coming into a system that's not really designed to handle way more than it should be there, it can be an issue. And when you have that sort of stuff happen, that's what leads to power issues. That's kind of the more extreme example. More or less, we don't really see that. We'll get into some of the impacts from getting a little more of this charged energy than usual out to space. But circling back to sunspots, what's cool about these kind of magnetic areas, or at least indication there's magnetic areas, it's kind of made by the moving of negative charges. I mean, that's what creates electricity. Our Earth's magnetic field, what's really cool is down in the Earth's core, where essentially it's just, let's call it magma. Magma is just the name for lava that's downstairs. When magma makes it upstairs, it's called lava, but downstairs it's called magma. As that moves, part of the spin of the Earth has something to do with it. I don't think I have the slides for that in this. But essentially, what ends up happening is by having this kind of negative charges flow, and it's kind of the same in the magma and different, I probably should be calling it magma that deep down, but different parts of the Earth's core, it leads to essentially a giant buildup of, let's say, charges around the Earth, that kind of Earth's magnetic field. And it's good because that plays defense. That blocks out a lot of this charged energy from the sun and prevents it from reaching Earth. But magnetic fields, let me just skip ahead a little bit. Magnetic fields and kind of the way our Earth works, I'm sure you've seen this picture. it kind of all converges around magnetic north and magnetic south. And as we know, the North Pole is not magnetic north. Your compass is not pointing to where Santa Claus is. Your compass is pointing to Canada. I think magnetic north is about 3 degrees off from the North Pole. But it kind of that magnetic field, it converges at the North Pole and it converges at the South Pole. So where some of this charged energy from the sun is going to spill in is around those regions, kind of where our magnetic field kind of comes together. And that leads, and we'll talk about it a little bit later, that leads to the northern lights and the southern lights. If you didn't know, if you don't get down to Antarctica that often, they have the southern lights just like we have the northern lights. But going back up to sunspots and talking about why we use them kind of as an indicator. So they let us know that, listen, the sun's been a little more active. It's kind of up in the ante a little bit more of its energy, at least at the surface, which means that's going to be that kind of extra boost of energy is going to be traveling into space. And yeah, it is cool that sunspots, I just think it's cool that you can see them doing some solar observing. And we were just talking about this, how the sun's entering a new cycle. It's dare I say, season, if you will. Lasts about 11 years. You have time where it's quiet, and then it kind of gets active, and it kind of goes up and down. This is the 25th one, since I guess it was either discovered. I don't know the exact science of why we're only at 25. Because let me see, 25 times 11, I think that probably would be about right when scientists started putting this together. But it's just a good indicator that the sun's being more active, and we should be more aware of this sort of space weather stuff. And it's really interesting because it can cause technology disruptions, which we'll run through in a little bit, the exact different types. There's been more and more research done because to a degree we are on borrowed time. Sure, even when it's been a little more active, it's not been that big of a deal. That's what's expected at about 5 years from now. But we could, who knows? We could in about 10 years, maybe 20 years, be in a situation where the sun is really sending a lot of energy our way. So it's, as the NASA scientist said, it's really important to be prepared, to be understanding that this sort of stuff can happen. And there's a lot more research, and I don't know if defense is the right word, but defense, we'll call it, being done for this. So the new weather, well, it's not new anymore, but 4 years ago, the new weather satellites that we get our cloud images for the TV station, the GOES satellites, they had more equipment on them to monitor space weather, monitor this charged energy from the sun, to kind of get more of a lead time to let Earth know that, hey, we're going to have a little issue, maybe power down your power grids a little more, prepare for that. So let's kind of break down all these different terms and what they all mean. Now, the fun part about science, and boy, you see it all the time in weather, we love using a million different names to basically say the same thing. There's one little nuance difference, and okay, there's one little nuance difference, new name. Basically, it all says the same stuff. So if you've ever heard any of these terms, more or less, it's exactly the same thing. Plasma, we talked about that. That's just gas that has a charge. Corona is the name for plasma around the sun's surface, so same thing. Solar wind is the name for that corona, which was around the Earth's surface. Solar wind's the name of that corona once it leaves the Earth's surface. Once that plasma is traveling through space, it gets called the solar wind. So that charged gas, I like to say charged energy instead of charged gas. When that charged energy is leaving the sun and it's traveling through space, it's called the solar wind as a kind of a general encompassing term. Solar flares are bigger bursts of that solar wind, bigger burst of that charged energy leaving the sun than usual, right? We talked about how there's always energy leaving the sun. Well, you're going to have these bubble ups, if you will, of these little bursts of it. And solar flares, they move super fast. They can reach Earth in a matter of minutes. Compare that to coronal mass ejections, which take days to reach Earth. And coronal mass ejections, essentially, when you have a really big solar flare, that can create also a little bit of a magnetic field. And again, we can get magnetic fields simply as just flowing negative charges can kind of lead to that. And these travel slower. These, as I was saying, these take days to get to Earth, which is good because we get a lead time. In fact, anytime you hear about the northern lights possibly being visible, let's say down here, I bet some of you maybe seen it over the years. We do get the northern lights occasionally. I know it happened in around 2010. It was in Lancaster County because I got some pictures when I worked for WGAL at the time. I remember as a kid seeing a weird faint color in the backyard one time. I've gone to both Alaska and Iceland. Iceland mainly to see the northern lights. Guess what I didn't see in Iceland? Yep, the northern lights. But what's cool is when you have these bigger bursts of energy that lead to kind of a buildup of magnetic field, and that kind of gets sent toward Earth, we have a little bit of a heads up. So we know this is coming. We know it's going to excite the air in the upper atmosphere, which leads to the northern lights, which we'll get into the science of that in a little bit too, just because I think it's so interesting. And you kind of get that heads up. But essentially more research is being done to better forecast not only coronal mass ejections for how soon they'll get here, but also more importantly, these solar flares that are that little bursts of energy that get to the Earth in minutes, just to give a little better lead time to the things that can be disrupted, like satellite communication. So anything that runs up a satellite, GPS, or we'll say radios for airplanes and different things like that. Okay, so where we're at. So coronal mass ejections basically made from solar flares kind of it's more about the magnetic charge move slower. Geostorms is the name for coronal mass ejections, essentially. You could argue it's also the name for anything that we have up there. Geomagnetic storm, just kind of more longer form, geostorm, all the same thing. We're all talking about this charged energy that leaves the sun and has potential to affect things here on Earth. And it's cool. You can kind of see right there a bigger burst. So there you go. There'd be a little solar flare of that charged gas leaving and heading our way. And it's just the amount of energy determines it. And this basically goes down to pretty much everything I just was saying. This is like the whole kind of sort of definition of it. And we'll skip it because I feel, we talked about it just plenty. Oh yeah, cooler things to talk about. So kind of getting back to the northern and southern lights, when we get a little bit of that kind of coronal mass ejection, that solar flare leading to the buildup of almost a magnetic field. Let's for lack of let's just for simplicity, call it a little bit of a magnetic field hitting the Earth's magnetic field. Some of that spills into Earth at the North and South Pole. It's always happening. That's why we pretty much have the northern and southern lights constantly up in those regions. Because remember, we're always getting solar flares. We're always getting, maybe not so much. We're always getting solar flares to a degree. They're just haven't been as big or as strong as they have been lately. So there's always some of this energy spilling in. It's just if you want it to be really big and really vibrant, one of these big coronal mass ejections to come by and have that bigger burst of kind of magnetic energy to spill in. So even though the Earth's magnetic field does a great job of playing defense, and it's a good thing we have it, because listen, if we didn't have the Earth's magnetic field playing defense for us, let's just say we'd be wearing spacesuits when we go outside. So Mars doesn't have a magnetic field. And again, the reason we have the magnetic field is because we have a liquid inner core in the Earth. And as the Earth spins, some of the metals that make up that core, because at the end of the day, it's just melted down rock, and we'll say metals. As they flow, charges build up. There's a kind of flow of negative charges that leads to a magnetic field. Because Mars, at this point, I think is all solid, there's no, let me see if I got something to back me up on that one. I was looking through these slides earlier, and it was funny. I was making decisions of which ones to put in and which ones not to put in. And of course, the ones I didn't put in to make decisions are the ones that are fresh in my head for some reason I want to talk about tonight. Real quick, I'm almost certain I put something in about Mars right here. Yeah, so Mars doesn't have, quick sidebar. I bet you guys know this. You can see the polar ice caps right now from Mars with the telescope. Pretty cool. So their core is solid, so they don't have a magnetic field. Because they don't have a magnetic field to play defense, the solar wind, that charged energy from the sun, literally strips away their air. Basically takes away their air. And that's why Mars has so little air on it. It doesn't have that magnetic field to kind of prevent the solar wind from carrying the air away. So it's a good thing we have our magnetic field. So we like that. But here's how the northern lights work. So in the very upper levels of the atmosphere, there, at the end of the day, is just kind of like the more basic elements. There's oxygen, kind of more so, the oxygen gas, the nitrogen gas. There's not a whole lot of it. But there's also kind of atoms. And what happens is when you get a little bit of this energy from the sun to spill in that has a charge to it, it collides with some of those atoms in our very upper atmosphere. And I want to stress this enough. There is virtually no air in our upper atmosphere. We live at the bottom of an ocean of air. 90% of all air on Earth is down where we are. It's swimming with us, if you will. So 90% of all air on Earth is our level of the atmosphere, the troposphere. Basically, 10% of air is right above that in the stratosphere, where we have good ozone. And basically, if your math is good, that was 100% right there. 90 plus 10 is 100. So that gives you a feel for how little air is in the mesosphere, which is where a lot of meteors burn up. I suspect the mesosphere will be having some visitors very soon, in about a week, about 2 weeks. And then a level above that, thermosphere, it technically would be where the International Space Station is. It's kind of weird to think. The definition of space is kind of open for debate, right? That most people consider 62 miles above the Earth's surface space. But technically speaking, if you want to get technical about it, as we talked earlier, I'm not one for being technical in terms of communication of science. But technically speaking, the International Space Station is not in space. There still is a very minute amount of air where the International Space Station is. So technically speaking, it's still in Earth's atmosphere. So I don't know if you can, really call it space. It's a definition sort of thing. I think it's space, in a real world kind of perspective. But, kind of up toward that level and bring it down a little bit more, you have these oxygen atoms, nitrogen atoms, maybe a little bit of the gas. And what happens is when some of that extra energy from the sun spills in around the north and south parts of the northern magnetic north, magnetic south, it runs in and it collides with some of those atoms. And we talked about earlier, the way to kind of make energy. You have collisions, that creates heat. So when those atoms collide, it's creating some energy. And what's kind of interesting is the energy that gets absorbed from that collision, from some of that extra energy from the sun that runs into the oxygen and nitrogen atoms that are up in the upper atmosphere. It's more atoms than it is gas. Kind of the gas would be oxygen gas is two oxygen atoms kind of bonded together. Up that level of the atmosphere, they're kind of more stripped apart. The intense sunlight kind of breaks them apart. So you're just left with the actual atoms. When they get that kind of that hit with extra energy that's snuck in from the sun around the poles, best example I would say is this. You get a fifth grader, it's Halloween night, you let that fifth grader eat as much candy as they want, they're going to be bouncing off the wall for what, an hour or 2 hours? They're going to be going nuts, and then, man, are they going to have a crash. And that's exactly what's happening up here. They get that collision. It's them eating all the candy, that oxygen and nitrogen. They gain this energy, but the thing is they're not designed for it. The structure of those atoms isn't designed to just hold on to that extra energy. So they have to get rid of it. And the way these atoms get rid of it is they get rid of this excess energy by giving it off as light. The light that we see, it's the northern lights or the southern lights if you're down that way. I was recently in Antarctica, which is like a lifelong dream to go to. I wanted to go to it for a variety of reasons. One, to kind of do some climate science and reporting. Two, I just was really always interested in it. Three, just on this kind of a silly note, it was my last continent. So I want to say I've been to all the continents, so I can say that now. But, I was kind of almost excited for a second. I'm like, oh my gosh, I can go see the Southern Lights. And I went, oh, I'm going down the time of the year where there's not much darkness. Of course, you want to go down to Antarctica when it's the warmer season, if you will. But it would be cool to go down to that region and see the Southern Lights in their winter season, though. I don't know if that's the place to be in the winter. Coastal Antarctica, no problem. The ocean water, and it is water, it doesn't really ice over that much. There'll be certainly sea ice cubes, if you will, in the water. But it doesn't turn solid like, say, up in the Arctic. So if there's liquid water around, then you can assume the water is somewhere around 32 degrees. That's going to moderate your temperature. Any coastal city is moderated by the temperature of the water. Once you start moving inland, different story. The coldest parts, all those record cold you hear about, that's inland Antarctica. Along the coast, to be honest, so I was down there in December, it was 32 degrees every day. It was colder here 2 or 3 of the days than it was when I was down in Antarctica, just to give you some perspective. And they were telling me even in their wintertime, it's only about 20 degrees colder. It doesn't really get that cold along the coast. So that's the place to be if you go down there. And so anyway, you're going to get more vibrant northern and southern lights the more of this energy that comes in to Earth from the sun. And certainly when we get a coronal mass ejection, so the solar flares that were really big, that basically kind of send it, if you will, a little bit of a magnetic, I don't want to call it magnetic field, let's call it a magnetic burst of energy into space. couple days when it reaches Earth, that's really going to excite those atoms. They're really going to take in that energy, and then they're going to have a much bigger crash. And as they just took in so much more energy than usual, their crash, their essentially the light they're going to emit, is going to be much more vibrant. So not only will be more vibrant, but it also will get to go into more locations than usual and come farther south than usual. Just checking the slide, make sure I didn't miss anything there. That's exactly what I said, so we can keep bouncing along. I will say this, I found the Northern Lights forecast that the National Weather Service folks or NOAA put out, not the best. they don't verify that well. I was using it in Iceland, let me down a little bit. But it's cool. I will admit why, yeah, this stuff can cause disruptions. I'm kind of looking forward to when the sun gets more active, because I would love nothing more to see a little faint green hue in our sky again. I think the Northern Lights are really cool. It's on the bucket list. If Europe were open for business this winter, I think I'd go up to Norway and actually go check it out. And I really look forward to the time I can see the real deal, like what you see in pictures. So let's get into some of the impacts. There's varying degrees. The solar flares are certainly going to be a little bit disruptive, but they're not going to be as disruptive on the scale as the coronal mass ejections, i.e. another term for geostorms. The ones that have kind of more of a magnetic field carry more of these kind of, we'll say, negative charges that can affect our power grids and affect different technology. So that comes to Earth, and there's a lot of different issues from astronauts. That's a huge deal. I mean, that's one of the biggest ones with these solar flares, these ones that travel to Earth in minutes. That's kind of scary. Let's say the folks at the International Space Station are doing, I don't know, they're switching out some solar part of their solar array or something's bad, so they're getting rid of the cell. That's real bad if they're out there. I'm going to send up some follow-up media to you guys. I did an interview. I'm not going to be able to find it on the fly, but I did an interview with a guy down at NASA in Florida, and he told me a really cool story, and I'm pretty sure I have it on camera. I can't remember if the conversation was on air or off air, but I'm not going to tell this right, and it's the way he told it was something wild. But basically said they do certain things. Oh gosh, there's certain procedures they'll do on the International Space Station if they know there's like a solar flare or some bit of not looking good for that. Let me think here if I named it a particular anything. Yes, it was cool. I went down and got to see a rocket launch down there. Let's say space weather. All right, we'll do one more time and I'll give up on that. Well, all right, so let's see. It's not space weather. Let me try. I'm trying to think what I would have named it. I'll do the legwork. I'll send it out later. But anyway, he basically said at points astronauts have basically been able to consensus on board when there's some more of this solar wind traveling through the air and something like, I'm going to do a terrible job remembering how he said it. It was something cool like this. This is not reality what he said, but basically he said something like with their eyes closed, they could still like kind of see light or something. You can feel the energy. It's really cool. I hope I can find it. I hope it's in the interview. I will find the interview. I know where the interview is. It's just a matter of finding it. So he was also telling me that the International Space Station, they have a certain procedure where they'll basically kind of, I forget what they turn, but if they know this is coming, they'll rotate or turn things in a certain way so they'll be less affected or it'll be less disrupted by some energy from a solar flare or energy from that kind of coronal mass ejection, that bigger hurl of magnetic energy. So that's a concern. For us, we're worried about in terms of satellites, just that extra charged gas is going to be like someone like kind of nudging on the satellite a little bit. Well, that's going to throw the satellite a little bit off course, so it's going to have to use its energy to put it back on course. If you're in a situation or a period where, let me actually get to that slide. If you're in a situation or period where you're constantly having way more of this charged energy run into our satellites, like our communication satellites or our weather satellites for that matter, they're going to have to use more more of their gas to get back on course. And essentially, it's going to go out of service a lot sooner because a satellite's done once it gets out of its orbit. And I mean, at some point, the connections will be lost as it drifts away from the orbit it was designed. But if we're getting more of this solar wind than anticipated, or just in a really active solar cycle, yeah, the satellites will go out of service a lot sooner. And so that's, that's kind of something to kind of be aware of. But kind of circling back around, let's take a little bit more of a kind of a look here at different things. We'll do with the doom and gloom one, the kind of like the worst case scenario, is talking about the coronal mass ejections, hurling out the solar flares that lead to that magnetic field, and that kind of magnetic field travels through Earth and it reaches us. That magnetic field is going to have a bunch of negative charges. What it can do is it can get into our power grids, namely, the best way to describe it would be this. It's my understanding that transformers are kind of the way to regulate the speed at which current moves, that we'll call it the flowing negative charges. And, if you have way more of those flowing negative charges than the transformer is designed for, that's going to happen right there. It's not going to have a good day. It's, for lack of a better phrase, it's going to blow up. And so that has the potential, to be honest, again, I want to stress, this is more like a worst case scenario sort of thing, but it is something that is plausible. That if, we have an insanely powerful coronal mass ejection come here and that enters our power grids, that really has the potential, if they're up and running, if we didn't re-turn them on or do some different procedures, which, by the way, the power companies kind of all prepare for. They understand why this is unlikely it can happen, and they do have a plan. Talking about PPL and other folks. But if it happens, it can be a real problem. I mean, at the end of the day, it's just going to stress the technology, and it's going to fry it. And then obviously, if you get too many of these transformers that regulate the speed, the flow of energy, the flow of electricity happening across the grid, that's going to lead to big time power disruptions. So that's kind of the worst case scenario, why we should be cognizant of this sort of stuff. This is a cool, I was reading this earlier, I forget exactly the summary, but this is kind of walk through pretty much what I said, why it's rare, there is potential for this to happen. And it's kind of, if you look at the PowerPoint a little later and kind of read it, I thought this was a little bit of an interesting read, but it basically summarizes what I was just talking about. We talked about the impacts of satellite. This is more of a solar wind sort of thing. That the charged plasma, way more than usual, hitting it, kind of pushing off course. It's got to get itself back on course. Other issues is if more of that kind of energy kind of gets in the upper atmosphere, it's going to affect the way that devices connect with satellites. This is not necessarily a great example. I don't think this is kind of like an apples to oranges sort of comparison, but if you ever stuck a straw through a glass of water, and you kind of see how the straw is bent, you can kind of tell like the way light's going through it a little differently. Essentially, if you have more of these charged particles kind of up in the air, again, I'm really simplifying down the science. That's the problem when you simplify down the science. It's not necessarily as accurate, but essentially, let's say for a real simplified down meaning, instead of the connection from, let's say, a GPS going to the satellite going in a straight line, it's going to kind of throw it off a little bit. There's going to be stuff in its way, so it's not going to be able to get there as well, and it's going to disrupt the GPS a little bit. So your cell phone can certainly have issues. Same with the airplanes right there. We got ANA, I think it's a Japanese airline. They're able to communicate with satellite communications. When we have natural disasters, FEMA is using satellite communication. So their radios and different things, the way they're communicating is through satellites. So really, in an emergency situation, that's the most important thing. Because when I think about it, cell phone systems go down in emergency. Everyone's calling in. The system goes down. So you want to use satellites. You want to use something that's not going to go down. And this kind of has too much of the solar wind charged energy from the sun. It's potential to do this. And like I was saying, the way it kind of like the signal, the path isn't straight, if you will. It kind of gets bent, and let me put that in air quotes. But really, at the end of the day, it just means this: the GPS is going to have a harder time locating. In other words, locating you. So the accuracy is not going to be as good, and you're going to have radio problems. And these impacts, this stuff has happened before, and this is why there's more forecast and research being done into that to better study that, because at the end of the day, we don't want our technology disrupted, or we want to figure out ways around that, or at least we want to prepare for that. And we chatted about, how the magnetic field blocks a lot of that solar wind, so at least we still have air. And I'm going to skip this, but it's just pulling out the piece of bad science in the movie The Core. I actually like that movie. It's not the best science movies, but it's a fun movie. I like the movie. And one of their premises is that the Earth's magnetic field shields us from the solar wind, which is accurate. But, some still enters each day, and, that's why we have basically the northern lights and stuff. They did do a good thing by saying without the magnetic field, the Earth would cook, and you could argue, you could argue that. More so, it's ozone that protects us from the nasty UV rays that would be essentially sterilizing us, if you will, killing the bacteria. That really blocks that out. But, at the very least, it would take away our air. So we chat a little bit about that. This is kind of interesting what we're just talking about, how if we didn't have Earth's ozone, and by the way, there's two types of ozone. If you want to go kind of the simplified route, there's good and bad. The science route is you have tropospheric ozone and stratospheric ozone. We live in the troposphere, so the ozone where we live, bad. Air pollution, smog. The good is in the upper levels of the atmosphere, the ozone out there blocks us from just some of the, like I said, the nastiest UV rays that literally, if they made it down here, they'd kill bacteria. They'd sterilize things. Some medical fields will actually use UV lights to sterilize to kill the bacteria. So the point is, Mars that doesn't have magnetic fields, doesn't have the ozone because it doesn't have air, because ozone at the end of the day is air. Ozone is a greenhouse gas, both of them. And essentially, you want a spacesuit on because you're getting the nasty parts of sunlight on Mars without some of these defense mechanisms. It's interesting. I just was sitting in on a seminar talk about ozone and air quality, and kind of an ozone expert. And so, you know how it all works with ozone. In the 1970s, the world got together and was actually able to solve a global problem, and relatively quickly. And got together and said, we need to ban these chemicals that get rid of the ozone. They were collecting around the southern pole, and there's an ozone hole there in the center of Antarctica. And what is a good thing is these chemicals only last in the air for about 100 years. So it was expected around 2080 that the ozone hole would be gone. Essentially, it would shrink because over time, more ozone is just naturally regenerated. And there's less of these carbons, these chlorofluorocarbons and such to kind of eat away at that. NASA's just kind of got some more updated research, and sounds like 2060 now. And it's kind of sooner and sooner that it will be going away. And what I learned is, and boy, I'm going to forget on this. I want to say it's either colder, it's one or the other, and I have a 50-50, right? When it's either colder than average or when it's warmer than average in that level of the atmosphere in Antarctica, one of them is really good and one of them is really bad. The one really good, it's just the ozone hole won't be as big. When it's the other one, it's not as good. I wish I remember off the top of my head which is which, but I thought it was really, really interesting. And as an effect of global warming, it'll, in theory, actually help the ozone hole regenerate sooner. And that would almost make me think it's the warmer one, but for some reason, if I had a guess on a multiple choice test right now, I'd pick the colder than average one. Is better for less ozone. I should cheat and actually pull up the guy's PowerPoint. I have it with me. But anyway, the main point was global warming is going to lead to the certain temperature where it's good for ozone regeneration around there. So that could be an unexpected, if there is any silver lining in something, that the ozone hole goes away a little sooner as the Earth's temperature rises. Kind of interesting. I wish I had the science down a little more pat to kind of share with you. Real quick, while we're talking about that sort of stuff, so the CFCs last in the air for 100 years. Just allow me for a second to point out a little climate science. So what's really interesting is the gas form of this, the gas form of water, is the most prevalent greenhouse gas in our air. Water vapor warms our air the most. So water vapor does, without question, the most global warming, period. Not carbon dioxide, it's water vapor. Why don't you ever hear about it? Even though water vapor is the leading greenhouse gas warming our air the most, you never hear about that. And the reason for that is water vapor is not staying in our air long. Very soon it becomes a cloud, becomes dew on your lawn, becomes rain. Very soon it becomes snow. Carbon dioxide, 20 to 40% of the carbon dioxide that's getting released right now stays in the air for thousands of years. And that's a problem because the more greenhouse gases you put in the air, the warmer the air gets. And it's almost a shame we call them greenhouse gases because greenhouse gases do not act like a greenhouse. A greenhouse physically traps heat. Your car with the windows up is a greenhouse. Sunlight goes through, it warms the surfaces in your car, that hot air gets trapped. That's a greenhouse. But greenhouse gases do not act like this magic layer. What they do is they absorb the heat the ground gives off. They absorb it, and then they re-radiate it off. They give it right back down. One of the best examples is a night with clear skies versus a night with cloudy skies. A night with clear skies, basically like tonight, will be 10 degrees colder than a night with cloudy skies. And the reason for that is this. Clouds are basically just a big area of water vapor. It's just a big area of humid air of greenhouse gases. Greenhouse gases are good at absorbing heat and then sending it back down to the ground. And yeah, they send some up above it and it goes into space too, but because they're really good at absorbing the heat and giving it back, it's warmer on a cloudy night because basically we have extra layer of greenhouse gases, and then literally you see the effect of it. It's about 10 degrees warmer. So that's the problem with carbon dioxide, and just the more of these greenhouse gases you put in the air, the warmer the air gets, and you keep putting more in, and we're going to have the carbon dioxide in there for for thousands of years, 20 to 40%. There's a lot of research being done on, it almost sounds like voodoo science, to say, how can we remove carbon dioxide in mass quantities? But that's where the research hit. And I personally believe, this is just my personal beliefs, I personally believe we're going to get in a situation all of a sudden we're going to get in too deep on global warming. And we're magically going to get the problem solved. I don't think it's moving along flat out because you don't really see it in your backyard. Sure, if you think about it, I would say, what winter did we have last year? The year before that, not that much snow. Compare that to years prior when we've gotten a lot more snow over the years. And, these days we're not getting as much snow as we have in the past. And I mean, that to me would be maybe only one of the impacts. Now, we need to see that trend happen for kind of years and years to say, okay, that's climate change. Because we can have one of these 1 or 2 off winters, but you can't say that's a trend until it consistently happens. People like to say all of a sudden we have one of these polar vortex that, where's global warming, And well, the truth is it's twofold. One, that's just a one-off kind of thing. Weather changes day to day. It's all about overall, the longer period of time, what's weather doing. That's what climate is. It's just the average of weather. And long story short, global warming will actually lead to these colder outbreaks. It makes the jet stream, the polar jet stream, more wavy, so this cold air can kind of spill down. But anyway, so kind of circling back to some of those greenhouse gases, I think it is interesting that the Massachusetts Institute of Technology has some promising, it sounds like, ways of looking at removing carbon dioxide in kind of mass quantities. And I think we're going to see more research and more talk about that over the next decade or so. If you ever hear about methane, methane warms our air way, way more than carbon dioxide. So if you have the same amount of carbon dioxide versus methane, methane's going to warm the air much more. I personally don't like whenever I hear someone talking about methane in the context of global warming, because to me, I feel it's a little bit of maybe an ignorant view, meaning this: methane only lasts in our air for 10 years. Sure, it warms the air much more than carbon dioxide, but to me, this is a long-term problem. Methane's not a long-term problem. So to me, I feel that's kind of like a lawyer sometimes does. You don't have to present all the facts. You just have to present the facts that work for you. And I feel when people talk about methane, they're presenting the facts that work for them. But anyway, I'm sorry to go on and rant about some climate change stuff. I just think it's important to kind of get that information. I think there's a lot of misinformation. I think there's also a lot of, I don't think it's really clear how that stuff all works, but maybe think about that, talking about ozone. Oh, this is cool. I think I have a couple pictures. Let me see how I'm doing on time, if it's okay. that's kind of the heavy lifting science. I want to wrap up with, I got a couple pictures. So this is neat. Down in Villanova University in the Philly area, they're basically seeing, hey, what plants grow good on Earth? They have a greenhouse, and their greenhouse is kind of dirty, and it works because, Mars is farther away from the sun. It's getting less sunlight. So they said, okay, it's actually about how dirty the greenhouse is. It kind of mimics the amount of sunlight that'd be coming in on Mars. Since essentially, you'd have to grow stuff in a greenhouse on Mars since there's essentially no air. This soil, I think, is coming from the Sonora Desert, which is out west. I want to say California, but if it's not Cali, it's definitely Arizona. And essentially, basically, it's just crushed rock. So the soil on Mars, more or less, is just crushed rock. And essentially, what you have to do is you have to add two things into it. You take what's there, which would be the crushed rock. Then you add, I want to say like some paper material. I forget the reason why. And then you need some organic material, aka worm poop, or if you've seen the movie The Martian, human. And that's what'll make things grow. And it was kind of really cool that's kind of similar more or less to Martian soil there. It's just basically it's crushed rock. It's not like the soil we're used to here. There's not a whole lot in it. And so this kind of works. Just talking through some of those stats, how it's farther from the sun, so it only gets about 40% of the sunlight. Compared to Earth. The biggest problem with Mars is it's kind of like that desert sort of situation. That kind of rocky soil does not retain heat. Our ground is our heat source. It's really crazy to think about this. Yeah, okay, I know the sun's our real heat source. I get it. But it's the ground that directly warms our air. The sun heats the ground heats our air. If you have a ground that doesn't retain heat, you're going to have these big temperature swings. You're going to go from being one temperature during the day and then way cold at night. Kind of what's going on in the desert. That's kind of more rocky soil. It's not really retaining or holding on to heat well. Just in case you're curious, the air we breathe, the air outside your door, it's not able to absorb the energy from the sun, i.e. solar radiation. It's only able to absorb infrared radiation. So like the energy our bodies give off, everything gives off infrared energy. If you had a certain camera lens, you could see that. I like to think of it as temperature. And so the sun heats the ground, then the ground emits that energy as infrared, and then our air absorbs it. And I just, I think it's kind of interesting that all the kind of the planning that's got to be done for, essentially, let's not kid ourselves. We're considering, I don't think it's a long-term sort of thing, but I think it's considering kind of, down the road, maybe colonizing Mars a little bit. And I think it's kind of cool. I don't know how soon that's going to happen. I don't know if I'll be around to see that, but I think that's really cool. And then and if you ever saw the movie Geostorm, I actually liked it. A lot of people ripped on it. The only problem with the movie Geostorm is we just got done talking about geostars, what they actually are, what that charged energy from the sun. This movie was not about any of that. This movie was about satellites controlling our weather. So they got it wrong from the start. I mean, what a great start if you got the title wrong. And what's interesting is we can actually control the weather. It's not fiction, it's fact, but there are some catches. China did this for the Olympics. They essentially made it not rain for the opening ceremony. And the way it works is this, it's called cloud seeding. And if you want to control the weather, here are the catches. It basically has to be from a cloud that's already going to produce rain. You can't find the middle of the desert where it's dry. Just drop in some silver iodine, which is more or less, think of it as dry ice. Think about what you see coming off of dry ice. These little particles that are in it kind of serve as little, I don't know the best way to put it. Let's call it focal points for moisture to come out of the air onto. If you drink beer or soda and you ever have some left over, get some salt on your table, throw the salt in the soda or the beer, and all of a sudden you'll see basically a cloud appear. Out of nowhere, all the bubbles that are in there will just be attracted to the little grains of salt. Same sort of idea, we're putting these little grains into moist, humid air, and the really humid air goes, whoa. And all of a sudden, the humid air, so the water vapor, which you feel on a hot, humid day, becomes liquid. Essentially, you need, in order to make a raindrop, at the center of every raindrop and snowdrop, there is a speck of something, a speck of pollen, a speck of dust, a speck of, an aerosol, some sort of air pollution, whatever you want to say. So you need a surface for the water vapor in the air to deposit onto to make rain. So essentially what this is doing is this. When you drop this chemical into a cloud, it excites the cloud, for lack of a better phrase. It extracts the water vapor out of it into little water droplets. Once you have enough of these water droplets in the cloud, they're going to run into each other. And all a cloud is, by the way, is a bunch of water droplets suspended in the air. They're too small to fall out of the air. They're too small to be affected by gravity. Well, so the more you get, they're going to run into each other. Now they're big enough to drop out. So you're essentially inducing rain out of a cloud that's already going to produce rain. And by doing that, you do two things. One, you make it rain. But secondly, you make it rain sooner. So if you don't want it to rain somewhere down the road, like in China for the Olympic opening ceremony, you see a storm tracking toward that stadium, you make it rain sooner. So that way, when that storm cloud gets to the stadium, it will essentially gotten rid of a lot of moisture and it'll be dry. And that's how you prevent rain. Or essentially, you can add the particles in there and basically get more rain out of a cloud. It's debated how accurate the statistics are, but the best sources I can find say you can get about 30% more rain out of a cloud that was going to rain by doing this sort of thing. I think that stuff's kind of cool. So I just thought I'd bring that up just because a poor geostorm gets it wrong from the beginning. But to the degree the movie's plausible. I mean, we can control the weather. The catch with this is, if you catch the subtlety, we can't do it on a big scale. This is more small scale, kind of localized stuff. And I think a lot of stuff's sort of interesting stuff. All right, so I wanted to keep it a more basic overview. There's much more I could talk about, but I know my time's approaching to wrap it up. So let me open it up to you guys. I hope you found that interesting, and I'm just curious if anyone wants to kind of continue the conversation, or we can talk more about any one of those topics.
I have a question. It's basically just a general meteorology question. Does have anything to do with the sun? It's something I've always wondered, and now I have a meteorologist to answer the question for me.
I'm here for you.
Yeah. What causes a jet stream?
Oh,
I know it's a band of air that goes west to east.
Yeah, good.
But I can't help but to notice it jumps all over the place.
It does.
Sometimes it's straight. Sometimes it dips all the way down to Florida.
Yep. Rare to get down to Florida, but it does.
Yeah.
So I'm going to answer your question. It's actually super simple, but I want to show you the jet stream first, if that's okay. I mean, I'm still sharing my screen. Good. Okay, I just want to let you know, this is going to be like visual overload, but I'm going to break it down once we're in there. This is the best way, the easiest way for me to find the jet stream. These are weather maps, just in short. Future radar. This is at cloud level. Is it dry? Orange is dry. Is it wet? Green is wet. So in other words, green's cloudy, orange is sunny, white's partly sunny. So everything matches up. So this is at the ground. There's the remnants of the hurricane, tropical storm. To be honest, I haven't been paying attention to it since I haven't been on air the last couple of days, but I'll be up to speed with that. It's cloudy there. So let's go up here. This one is the upper levels of the atmosphere, which is what we're going to talk about. And really what it looks at is rising air. Red's rising air. Rising air is how you make weather, how you feel storms. And falling air is how you have nice weather. So where you have falling air, we should have sunny skies. And let's go down here. And yeah, more or less, there's some sun there. And it's a bad example. It's not dry there, but whatever. So up here is the jet stream. These lines are, we'll talk about these lines in a second, but basically, this is the jet stream, and wherever these lines are closest together is where the jet stream is. This is not a good example because the jet stream is very horizontal, but I'm going to take this through time, and I'm going to look to see if it's a little bit wavy or not. Okay, great. Here we go. Perfect. Here's a bigger dip in the jet stream. You see that right there? So I'm outlining it with my mouse. So I'm just going to where those lines kind of are in the middle, and so that's a dip in the jet stream. Here's what the jet stream is, and we'll come back to that in just a second. The jet stream is the meeting ground for cold and warm air. When you have a big mass of cold air meeting a big mass of warm air, so cold, hot, opposites hit each other. It makes wind, and here's the reason why. Cold air is heavier, it's denser, it wants to sink. Cold air weighs more than warm air. And think about it, warm air is light, it wants to rise. I don't know about you. I have an old house. Listen, I have AC going, but in the summer, I know that warm air rises because even with the AC, it's still warm upstairs in my house. So warm air is light, it wants to rise. Warm air doesn't weigh as much as cold air. If I went and literally if I got my water bottle, I went down to Florida and I just went like this in the air and I capped it and I weighed it. And then I went up to Canada where it's, let's say the North Pole where it's really cold and I did the same thing and I capped it and weighed it. My bottle will weigh more from the air in Canada than it will from the air down in Florida because warm air weighs less than cold air. And really what it comes down to is this. Cold air contracts, warm air expands. Because cold air contracts, there's more of it in its space. Warm air expands, there's less of it in space. That's really the science behind it. But anyway, so for our purposes here, cold air weighs more. So on the cold side, there's more air. On the warm side, there's less air. The Earth hates that. When there's more air in one spot and less in another, boom, you made wind. That's literally how you make wind. When you feel a breeze outside your door, we've been having some breezes, that just means there's more air in one spot right by you and there's less air in another spot. And you're feeling the air move from where there's more to where there's less. So let's think about this. You have this massive amount of more air, cold air, hitting this massive amount of warm air, less air. So you're going to make wind. Air is going to go from where it's cold to where it's warm. And when they hit, that's how you make the jet stream. Because there's such a big, massive amount of more air on one side, less on another, it creates wind as the air moves from where there's more to where there's less. And so that's what the jet stream is. So that's what creates it. It's cold versus warm, more air in one spot, less in another. But then secondly, it's the battleground. It's the fence, if you will, between cold air and warm air. So here's what I mean. If the jet stream is south of us, so let's say my mouth is Pennsylvania, okay? When the jet stream dips down south, we're now on the cold side. Our temperatures are colder than average. When the jet stream's over us, basically average temperatures, and we're getting the storms, because remember, the jet stream's a storm track. Because it's that area of fast winds, it pushes these big areas of low pressure. That would be a big area of rain. Nope, let me back it up. All right, let me find it where it was wavy again. That was good. Okay, so there's a big area of rain. So right there's cloudy skies, there's the rain, and it's literally riding the jet stream. Because the jet stream's a big area of fast winds, that's what pushes our weather across the country. Our big weather makers, big areas of low pressure that bring a lot of rain. Really nice days, high pressure, it's getting pushed by those fast winds. But getting back to what I was saying, when the jet stream's south of us, we're colder than average. When the jet stream's north, now we're on the warm side, we're warmer than average. But yeah, anyway, to answer your question, sorry to get so long-winded. It's where cold and warm air meets. The one side the air weighs more than the other side. I can't have that. It's just like if I connected a water bottle that was full to one half full, the water bottle that's full is going to run into half full to even it out. That's what's creating the jet stream. There's just so much air on both sides because it's in a massive state that it creates wind. And there's not just one jet stream, there's multiple ones. This is the one that we're particularly, that affects our weather. By the north, closer to the poles, there's a polar jet stream. To be honest, when you hear the polar vortex, we actually never get the polar vortex here. We get cold air from Canada that's usually up in Canada to slide down here. The polar vortex, in a definition sense, is actually just is just the jet stream around the North Pole. And every once in a while, it gets wavy. And when it gets wavy, it pushes some colder air that's usually in Canada down our way to get really cold. But we actually don't ever get the polar vortex. Northern Canada would. So does that answer your question?
Yes, it does. Thank you.
Yeah, I think that stuff's interesting. I think it's cool how jet stream does two things. It affects temperature, because like I was just talking about, and it moves our weather along. If the jet stream's over you, you're going to be getting a lot more storms. If the jet stream's like down in Florida, that's Florida's problem for storms.
Yeah.
The jet stream very rarely dips that far south. Like if I run
I've seen it there once or a couple of times, and then always talk about how the orange crop's going to fail.
Yeah, well, listen, because you know why? It's a big dip, so all that cold air is
all that cold air goes right down to Florida.
Exactly, and that's, the frost is the enemy of everything. Cranberries, I went last fall I always want to go to a cranberry bog and tour them. And during the summer, they have to be really careful in the fields because, it can get a little colder down at the ground, and, frost will mess it up, just like frost will mess up the oranges. Hey, real quick, because we're talking weather. So this is October 16th. Excuse me, this is October 15th. Weather time's 4 hours ahead. I see a kind of a decent dip in the jet stream. It looks like it's going to get cold toward the end of next week. So let's see here. This is a, let me just kind of play this out a little bit more. So yeah, so that's definitely a cold front. Anytime you see a line of rain on radar like that, that screams cold front. That's a pretty hefty dip in the jet stream, and that's going to slide into our skies. I can't say it'll still stay like that kind of bowling ball shape, but what I can tell you is the weekend of the 17th is going to be definitely colder than average. You can bet on that one. So we'll see if I verify. You've been told, you've been warned. We'll see how that verifies. But definitely, it's clear to me that looks like we're gonna get a dip in the jet stream that come in that weekend. And definitely get some clear.
Of course, I'm going to the beach that week.
It might be a little cool down there, but listen, maybe it won't come down your way until like the end of the weekend. So you might be good. And listen, that's the beauty of weather. We're a little far out. The models change, but to be honest, in the grand scheme of things, this has actually been showing this cold front setup for a couple of days now for that kind of toward the end of next week. So I think it's very safe to say at some point toward the end of next week, we're going to get colder than average. How colder than average? Well, that's too far out to tell. But right now, I would say at least 10 degrees. So for average highs in the mid-60s, I would say that's like 55-degree highs. But at the end of the day, it'll probably be closer to like upper 50s would be my guess for next weekend.
You hear me if I want to ask a question?
Yeah, what's up?
Oh, I might have had that. I just clicked that red corner of the screen. Well, I'm reading a book by David Wilcock, and it's called The Synchronicity Key, and he talks about how the sun and the stars emit. I think it's your plasma and your solar wind that he's talking about.
Yep, all the same thing.
When it emits the particles from the sun and the stars, they actually are microorganisms, and they are live, and he calls the sun and the stars as live organisms, and he says that when they hit space, it's cold and it deep freezes them, or what do you call it?
Yeah, it would be a deep freeze. Yeah, sure, I can understand that. Yeah.
It freezes them, and then it looks like dust in space.
I'll put it this way, from a scientific standpoint, I personally couldn't even buy any of that just because the sun is so hot. I don't understand how any organism could survive that intense heat, because at the end of the day, that energy is leaving the sun with that intense heat. Sure, I can absolutely buy the fact that as you're traveling through space, it can into stuff like, let's say, some comet debris.
Right, he called it.
Well, that I agree with. You can run into comet debris, and there could be organisms in some capacity there, and then it's kind of in a deep freeze, if you will, and then comes in. And if it doesn't get burned up on the way down into Earth, you can make it. The Earth's going to get filled up. But what I will say is this. Don't quote me on the planet. Maybe you guys can help me out. I believe it's Venus. But one of these planets with a kind of a gassier upper atmosphere, it's my understanding, just recently, it was basically scientifically confirmed that there is, I think, phosphorus or some sort of chemical.
Phosphine.
Thank you. Yeah, you know where I'm going with this one. Yep. That essentially it's not like essentially an organism or something, but essentially it's the building blocks for life. And if that were to make it down to the ground, that could lead to things. And long story short, you could argue that that's kind of our first discovery of extraterrestrial sort of a life form. Is it technically a life form? No, but the argument is that it implies it, and I'm too ignorant on all the exacts of it. But that I'm buying what we're selling there. As for what they're selling, listen.
You're buying that.
Just because the temperature extremes, I can't. How could anything be alive when the temperatures are so hot on the sun? How could anything leave the sun?
Venus is really hot.
It is. It is. But in the upper levels of the atmosphere, it's my understanding, it is not as hot. So down by the surface. So let me think about this. I think Venus is like 780 degrees on average because most of its atmosphere is greenhouse gases. I think like 96% of Venus is greenhouse gases. I think what we were just talking about is in a different, I don't know. The science sounds a little rocky. I hate talking about things I'm not well informed enough on. But I don't know. You bring up a good point. I'm gonna put it this way. You gave me homework, and I'm gonna research what's going on with Venus and see if it's in that hot atmosphere. I guess I shouldn't. That's the beauty of science. In science, you can't ever say something's not possible because you don't have the evidence to say it's not possible. We have to assume what you just said is 100% accurate, and then what you do is you do testing to confirm that it's not accurate, because that's the beauty of science. And science changes over time. For me personally, it just doesn't make sense in kind of the way my brain's wired, in that I don't understand how anything could be survived that kind of intense heat. I understand that going in like a deep freeze, that I get. I'm all in for that if it picks something up. What I would sooner guess is maybe
the astronauts saw particles outside the windows that looked like plankton when they were up there, and they showed that on TV and stuff. And so what are those things floating around in space?
I have no idea. I don't know enough to even say anything. I mean, I don't know. I mean, I don't know. I think there's a lot we don't know about space, and there very well flat out could be that sort of stuff. I mean, my personal guess would be it's just some sort of comet debris, because let's face it too. Not only is it kind of dust with comets, it's also these volatile gases that kind of just vaporize. And I think what I would think, and just again, this is just my personal thought, just based on the little knowledge I have of this sort of physics, astrophysics, is that I would imagine if there is that sort of stuff, it's something within the comet debris, kind of going back to when the solar system was formed, and something in there can maybe interact with, here's a great example. Humid air on a humid day is like a magnet for, I call it gunk in the air. Humid air really holds on to pollen, dust, all that sort of stuff, and that's why we have kind of more hazy sunsets. But I could see as this charged energy moves through space, it picks up some of that, whatever you want to call it, comet debris, whatever. It picks up some of the stuff that's in space, maybe what you're talking about, and that just kind of gets, like, let's say, kind of trapped into it, and then it's in this deep freeze, and then maybe it goes somewhere if it doesn't burn up. That I could see, but at the end of the day, I am just not the right person to answer the question, is what I would say. All I can do is use the science that I know to make a deduction about things, but I think anything is possible. And
are you going to take a space ride on one of what's his name?
No, we'll leave it. I'm good, but I'm excited for the Tom. You guys heard about the movie? Tom Cruise and this director are going to go into space and literally do a movie. And that
was awesome.
Like legitimate story, not fake news. Like, it's a done deal. A studio's on board. Like, there's literally going to be a movie filmed in space, an action movie. And he, the director, and I think Tom Cruise are going up next year on one of them to do, like, basically some we'll call it research, kind of their shot location sort of stuff. So I think that's pretty cool. Kind of, I want to piggyback real quick, and I'll go to that question I saw someone sent me in chat. I ran into a really nice gentleman on a hike when I was in central Pennsylvania 2 weekends ago. And he told me about this. I've just been so darn busy lately, I haven't had a chance to check it out. He told me about this guy who's like an academic that kind of brings up really unique ideas, kind of like the stuff you were talking about that's not maybe as mainstream, and basically talks about kind of the peer-reviewed science and delves into it and really kind of basically doesn't rule anything out. And when I send out some content to you guys to look up, including that NASA interview I hope I can find, where he talks about how the astronauts like saw lights through their eyes and what they do with the solar wind, I'm gonna look for that. There's a couple other things I want to share with you in my PowerPoint, but I'll send a link to this. So it's called Suspicious Observers. And from my understanding, he just takes these topics and kind of looks into really unique kind of science and brings up some of the peer review. And it sounds pretty cool. If I can, let me pull up my email real quick. And I think he might have gave me a summary of the sort of stuff. I'm not gonna lie, I don't remember the conversation as well as I should have. And it's been on my list to check it out. And it's just, listen, we have only so many hours in the day, and I got to get to the more pressing things before I check out the cool stuff that I just want to kind of enjoy. Okay, so let's see here. I think he gives a quick summary. Let me pull this up. Well, all right, so let's see what this says. As this pulls up, let me check my little chat window. Okay, perfect. He doesn't give a example, or I was hoping we get like an overall summary. But I don't know. Check it out. It might be really cool, and you might really think it's neat. And let me put it this way: this guy sold it to me. I would want to watch the content. It sounds like a really neat podcast.
On
Sort of.
YouTube?
Yeah, it's on YouTube. So there it is. It's called Suspicious Observers. I'm gonna see if I can click on it to see if we can to see like if he had like a little summary of like what it is. I'll go to his Facebook real quick.
Very cool. I've seen those videos. I haven't watched them yet.
Yeah, let me put it this way. This guy sold me on watching him. I heard I heard it's really cool. I heard it's really kind of obscure science, but it's looked at it from a very scientific standpoint, and that it's really neat. It sounds like some pretty cool stuff.
Question. It's not very science-based. You brought up 3 movies. The second and third, I think, were Geostorm and Core. What was the first product?
The Martian.
Yeah, The Martian. Yeah, we love The Martian. That was one of the more accurate movies. The one big flaw, really the only one flaw that they had on The Martian, is The Martian's kind of like when you walk on Mars, it'd be like walking on the moon. You're gonna have a big bounce. They didn't get that right because of the gravity's a lot less. So you should have like a nice big bounce on Martian. That's the only one egregious flaw.
And the wind.
Yeah.
Premise.
Yeah. But otherwise, that was not a bad movie. I like that one. There was a really cool documentary, and I'll send this out all too. It's called Science versus Cinema. It's this physicist at a school, and he's a big movie buff, and he watches kind of like these movies, and he goes through what they got right, what they went wrong, and this is great. If you've seen The Martian, take 20 minutes and watch this. This is fantastic, and he's got other ones if you like it, and it was really good. I actually just saw it. I'll have to watch that, and I'll send a link out to that. It's a well done documentary, and it's engaging.
Second, unrelated to science question. You mentioned going to Iceland, and you asked, "What can we guess? What you didn't see?" And my guess was ice. Did you see ice?
Oh no! I saw plenty of ice in Iceland. I was saying the Northern Lights. I was just kind of making a joke that I've always been interested in Iceland. I loved it, and that was one of the coolest places I think I've been. I really liked Iceland. I really liked Newfoundland. Both really cool for different reasons. But yeah, the Northern Lights is what I didn't see. Just reading the comment. No, it's all me. I'm full. I don't even do coffee. This is me all the time. This is what I'm made for morning news. So yeah, no, there was plenty of snow, and Iceland was just a really cool place. I'd like to go back in the summer because all the rocks there are volcanic. So I'm used to rocks like how we have here. The rocks in Iceland are basically black. They're all volcanic rocks. They're black sand beaches. I love going to places that are so unlike where we live. I love going out west to where all the rocks are red. I love experiencing places that are completely unlike what I'm used to. I think it's awesome.
Drew, I don't know if you can see my screen or not.
I don't think so. I need to stop sharing, and I think you can take over control. So you can take it now.
Okay, there you are. You were hoping to see the Northern Lights sometime. I had an opportunity to see them several times from here in Berks County, but
Cool.
the best one I saw was in 2003 up in Cherry Springs State Park in Potter County.
I know Cherry Springs. Yep.
Yes, and I got a picture here. I don't know if it'll work, but This is the picture I took of the Northern Lights.
Oh my gosh! It looks like the real deal.
Yeah.
It was incredible.
It was phenomenal, and
It was big.
There's like 3 little white spots on the
I see it.
picture. Those are the stars of the Big Dipper. In
Wow, that's pretty cool.
and it lasted over an hour, and it was a remarkable time, and we were all there to view this dark sky, and we ended up seeing that. And that was part of a CME that happened that day that we didn't remember. And you mentioned about a coronal mass ejection in 1989 in March, and that's when the power grid went out in Quebec.
Oh, okay, so
you mentioned that in your PowerPoint.
I was talking actually about a century earlier, the telegraph one in the 1800s. But I know exactly what you're talking about in Quebec. So when I was driving back, I drove back from Newfoundland, And essentially in Quebec, that province, basically the power for New York City is generated there. Like I remember driving past it, it was like wild, and I can totally see how that would have been affected. I'll have to Google that a little bit more. But that's interesting. I didn't realize that. I remember hearing about that, but I didn't realize it was out of Quebec, because that would be a real issue for us in the
Yeah.
Northeast.
One of the interesting little side effects
Yeah.
of that particular event was just before the power went out, the infrared came in and caused people's garage doors to open and close all by themselves. And that was what people noticed before the power went out.
Wow, that's pretty cool.
So that was some pretty strong burst of energy from the sun.
And listen, that's the kind of potential, and that obviously pretty strong, but it can be much stronger. Obviously the sun must have been more active during that period, certainly in the early 2000s in the cycle. And it's just like with anything, things over time change. You have slower periods, you have bigger periods, but I listen. From a human standpoint, I don't want to wish any of that sort of stuff on us. We don't want to mess with technology, but from just a cool perspective, I wish we were I wish we had stuff. I want to go see the Northern Lights in my backyard at Cherry Springs. I want to hear stories about the power grid going, because I think that stuff's so cool. And it's crazy that something basically out of our control is affecting this. Something out of this world is affecting our world. I think that's incredible. Yeah. Well, hey, anyone else got anything else? Any other weather questions? What do you got? You got me.
Microwave?
What about microwaves?
Would that solar, like he said, the garage door went up and down? Would it affect the microwave in your house? Like turn it on and off? I gotta unplug my microwave. I'm worried now.
Don't. You know what? I don't think that stuff would give a power surge in our house.
Why did it do it to the garage door?
Because that's the remote controls work on infrared.
Yeah, it's just the energy. It's a different types of. Like, let me put it this way: if your microwave was on and you got way more microwave energy in your house than usual, that could potentially be a problem. A microwave's really interesting how it works. I don't know if you know how a microwave warms up food, but essentially it makes the water molecules in food vibrate. And when you get them to move, it has collisions, and that creates heat, and heat's generated by literally making the water molecules in the food vibrate. And also that's why it dries out your food, because it makes that water, the moisture that's in it, evaporate, so it gets drier.
I had a question about solar cycles.
Yeah.
So we just started a new solar cycle. Solar cycle, I don't know.
25, yeah.
25. And how long does one of these solar cycles last? And can we expect the solar intensity to grow over that period?
Yeah, so about 11 years is about how long it lasts. And what's interesting, it's not exact science in that this one started in December of last year, is when scientists have figured that out. But NASA just basically declared it in September. Because it's not an exact science, they have to watch for these trends to be able to determine it. So, after watching for months and months, they said, okay, yeah, we definitely should, change the stage. And usually you have this cycle where it goes from being quiet, which we're in now. So it ended with it being quiet. It's going to start with it being quiet. And then as we approach the next couple of years, we're going to start seeing more solar flares. You're going to, sunspots. You take out, do solar observing, you're going to start seeing more sunspots. The estimates right now is in about 5 years from now is when it'll be at its most active period. Somewhere between 2024, 2025 in particular, maybe 2026, that'll be when it kind of spikes in its activity, and then it'll wane again. So it kind of is like, what do you want to call it, a parabola, where it's quiet, it spikes, and it comes back down.
So we can.
I have a question. What makes that happen? Why are there like seasons, so to speak, on the sun? How do you know that that's going to happen?
Ooh, that's a great question. I do not know the answer for that. I was going to give a recommendation for another guest speaker, that NASA scientist I spoke to, and that's his whole field. That's all he does and studies is the solar energy.
I think the astronomy teachers know that they have a history cycle. In my astronomy book,
it's definitely a cycle, but it's just the question is what why does the sun do that? Why does the
I
sun?
think it has part to do with the magnetic field because every 22 years the poles actually flip on the sun.
Okay.
Yeah.
I didn't realize that they have poles, but I would definitely think that. But I would just be curious, though. You know, what is the what is the impetus for that? Like, that's interesting. I'll tell you what. I got about 2 homework questions. Let me write that down. I'll see what I can find on that one because I think that's really interesting.
My understanding of that is I believe the sun is actually considered a variable star, but the variations are not very great.
Yeah.
We lived around a sun that had extreme variations the kind that we observe in deep space. Life wouldn't be habitable here on this planet. But the variability of our sun is so minor and is predictable that the minor variation only lasts 22 years, as Barb said, but it's not great enough to affect life here. But a large variable star would completely annihilate life.
Yeah. Right. That sounds. Let me put it this way. I'm buying what you're selling there. I'm still going to Google it and check it out a little bit, but that makes perfect sense to me. Because I can tell you what basically creates sunspots to begin with. I mean, granted, it's definitely these kind of more areas of magnetic charge, but the reason it's cooler is at the end of the day, the sun is. This is again, I'm really simplifying down the science. So basically, the sun is a lava lamp. You're going to have hotter areas in the sun, just like with our lava. And part of the reason we get like some types of volcanoes, these what are called hot spots. Essentially, you're going to have, for whatever reason, areas that got of this hot gas, like on the sun, or this hot magma that got warmed up more than usual. That pocket's going to rise. It's going to hit the surface. And then eventually, when it hits the surface, it's going to be a little cooler. And it's going to come down. And so, really, I think that's what. I don't think I've had.
The information I've gotten from our Night Sky network that we belong to, they give us PowerPoints and stuff. The sun's magnetic field lines aren't regular like on the Earth. They're all twisted up, and when these magnetic field lines get really twisted, that's when the sunspots pop up.
Yeah, you know what? That's the best way to put it.
Plasma follows up.
The NASA expert, what's one of the things I'll send out to you guys. I have about a 7-minute interview where he kind of gets a little more into this, and he's great. Basically kind of explain that in that sort of capacity that these, it's kind of like a rubber band. We have the solar flares. It makes a little sort of energy, but it's almost like the magnetic field, like what you just said. It's twisted up, and it's kind of like a rubber band that basically snaps, and that energy hurls. And yeah, that makes perfect sense.
So what you're saying is the 2024 solar eclipse is going to be magnificent with all of the.
You will see a lot of corona, probably more corona than we did in 2017.
You see a lot of prominences if you look through a solar telescope.
Yeah, is anyone going, making your plans? I know it's going.
Oh yes.
I'm thinking about. I'm going to head out west. I would.
The prediction
it's going to be the eastern.
The best weather prospect is Baja. That's where I'm going.
I would just say this: stay away from anywhere around the Great Lakes because the water will lead to pop-up clouds, like kind of convective clouds. So make sure, even though it's tempting to go to, like, say, the Buffalo area or Cleveland or wherever it's at, go farther west, and it gives you more options. Here's what I'm going to do. I'm going to go way far. My plan's going to way far west, and then I'm kind of basically in the middle of the country. I can go where I need to go if the weather's not going to be good. Is kind of what I'm leaning toward.
Yeah, it's like coming up from Texas through Erie.
Yeah, so I would just recommend why it's tempting. I mean, you can, and I think it'll be fine, but I just would say clear skies is going to be very unlikely around Erie, Cleveland, that region because of the Great Lakes. So I would caution, if you want to do it right, that region going there.
You're not going to give us a 4-year long-term forecast.
I can tell you exactly what the forecast is. It's whatever the average weather is. If that's what you do in a long-term forecast, I'll give you the average.
Okay.
It's going to be hot. Actually, I think it's the summer, right?
It's April 8th.
Okay, it's going to be, April's a terrible time for something like that.
It is. It is.
Dry place. Make it to a historically dry place.
Yeah,
right. We're holding you to this.
I would sooner get down to Oklahoma, Texas, because that's going to be just out of the gate. That's where the driest weather would be, just on average. And then the plains is going to be a toss-up. It's either going to be dry or it's there could be storms. I mean, start getting storms then. That's a shame it's not later in the summer.
So-
August was a great time for one.
It was.
October would be the best. One last thing I'll add about northern and southern lights. Our best time to see it's October. Basically, the change of seasons for spring and fall is the best time because just the way the Earth's tilted, we're more receptive to this energy from the sun than usual. So a lot of times, and you can actually, you can let me know when you got your Northern Lights picture up, Cherry Springs. Was that October by chance? Because I remember October was the one in 2010 when a lot of people saw it.
It was September.
Yep, exactly. So pretty much right around when fall starts is our best chance because let's face it, spring, April showers bring May flowers. It's going to be wet and cloudy and pouring in. It's usually drier in October. And so really what I like to say is if we're going to see the Northern Lights, and again, you can see them any time of the year in theory, but right now, literally right now is our best time to see the Northern Lights if they were, the energy from the sun.
So in future forecasts, will you be giving any on weather on Venus and Mars?
I'm going to do a story about kind of some of the stuff I talked about the climate science at the end of the year, and I will probably point out that it's 788 on Venus because I won't give the stats because I'm anti-giving stats on TV. I don't know, let me rephrase that. I like giving a stat about the weather like it was the first warmest year, but I try to not use like numbers Venus's air is 96% carbon dioxide. I would say most of Venus's air is carbon dioxide. Just again to kind of get rid of more of some technical stuff, even though it's not really technical. But I should talk about. I think I was just talking about. You can see what the weather's like on Mars, and we're talking about Mars over the weekend. I think I'll pull up that Twitter and get the weather report of what Mars is just fun on Saturday. Just because you said that, I'm going to do that on my graphics lineup. After I talk about Mars, I'll pull up what the weather is on Mars.
And maybe
You guys have seen that, right? That Twitter that tells you what the weather is on Mars. It's cool. It's really cool.
Yeah, I look forward to seeing your forecasts on Mars, and maybe the moon.
Yeah.
Break on the moon would be great as well.
Yeah, but I can do a live weather from the moon. There'd be a little bit of a tape delay.
Yeah.
Not bad. I think that's cool as we learn about more of that. It's like I think it's a 45-minute communication delay. So the astronauts will say, we arrived at Mars, 45 minutes later it gets on Earth, and the Earth will say, congratulations. And then at that point, an hour and a half later is when it gets back.
Mm-hmm.
I know that's one of the things they're working on, and I don't know if there's going to be a solution of how we can get the comms a little faster to Mars. And I don't know if the science is there yet, but I know there's research being done on how can, it's light speed, but at the end of the day, how can we lessen the delay? I don't know if that will be solved by the time we do mission to Mars and hopefully 2030 if it's still on track.
There's certain laws of physics you can't break.
I was going to say, I don't think it's possible to break this one, but I know there's still, NASA's still doing research on it.
Optimizing.
Yeah. Hey, you know what? Listen, sometimes you got to dream big. You never know. I agree with you. I think physics, there's some certain things that's that, but that's the beauty of science. You don't know what you don't know.
Where's the wormhole?
Yeah, that's cool. I was watching Neil deGrasse Tyson talk about that not too long ago.
So do you have the same weather computing resources that something like, the 45th Space Wing or 25th Space Wing, something like that, that hauls range and weather control for launch sites, such as the Mars facility, the Mid-Atlantic Regional Spaceport, basically Wallops Island, Virginia?
So kind of interesting stat. I stumbled on by accident. A guy who used to do weather for like a year here right out of school works there. And they did an interview with him. If you Google WFMZ and that 45th or whatever, or I can Google it real quick. It'll pop up in my history because I don't even know how. I ran across it looking for my NASA article. I Googled probably NASA WFMZ former meteorologist. In the meantime, as that search is, they might have there it is. So former, let's see, now forecasting for NASA. But there was an actual article where this is it, September.
Cool.
Oh, back in May.
Where's Ed Hanna?
He was, let's see here, SpaceX launch, kind of cool. And so I guess they talk about that. They do a little interview back and forth. So check that out. Yeah, well, everyone has the same information. Like National Weather Service has, they might have like an extra like model for comparison, but basically we all have the same information since we all have it on different platforms. I don't think they have anything different than I put it this way, anything they have I could get because, you know, our graphic system's just for air. Like we have the same graphic system as anywhere in Philly, but from a forecasting standpoint, it's just data sources. And really at the end of the day, I mean, there's 3 different sets that you use. So let me see here. Okay, good, I'm sharing my screen. So you have weather maps. So actually, let me get a nicer one. So you have future radar and other things that tell me data. So there's a whole slew of them. Then you have a text version of those weather maps. So instead of looking at a map form, I can look at it in a code form. And this is basically the weather map, but in code. It makes it a little quicker, a little easier to look at. Like this is just telling me for the next 24 hours with the cloud cover in Town at the airport. And then, you know, that's kind of the forecast I would need for everyday life. But the folks down at NASA, they're going to really need this stuff. So this will be a forecast for literally every layer of the atmosphere. This is essentially ground level stuff. And then as I go down, you're going up higher and higher in the sky. So we look at that instead of height, we look at it in terms of pressure because more or less pressure corresponds to height. And so this gives me stats on what's going on, like what's the temperature, how humid is the air, how dry is the air. More importantly for these guys, what they really care about NASA, they care about 2 things in particular. They care about temperature and they care about wind. So they're going to use more of this extracted data. There's other ways to look at this. You can look at this on a graph. I personally don't like looking at a graph. I'm one of the very few meteorologists that don't look at this. If I needed to on a graph, I look at it like this. For me, this just works better the way my brain's wired. But they're going to be looking more about the profile. In other words, the kind of from the ground all the way up in the air. They really need to study and forecast that. You know, the ground conditions, that's cake. That's easy. It's this stuff they have to be particularly concerned about. So yeah, I don't know if there's a launch or something and you want me to get you data somewhere, just let me know. I can get you the whole profile on the way up. You can get wind direction stuff on the way up or anything you want. Send me an email. I'll get you anything you want.
That is so cool.
So I know it's like textual overload, but you know, it's just, you know, these are just basic things. This is just different stuff. Basically saying like, what's the potential? If there was going to be hail, how big would it? At a potential, like how big is it? How much rain's going to fall? So it's pretty much dry till. Oh, I'm terrible at mental math. Whatever. So 3 days from today's what? Thursday, Friday, Saturday, Sunday. So it looks like Sunday evening we get some rain. This model is overdoing the remnants of the hurricane, but let's just slide through to see what it's doing for fun, just, you know, just we can. Okay, I'm buying this now. So earlier in the week, this model wanted us to really get the remnants of rain, like big heavy rainers. However, another one we compare it to, which is the European computer weather model, which is just another person's opinion, if you will. This one was dry, and I don't like when models disagree. Because if you have one saying basically it wasn't like dry, but basically it wasn't having as much rain. If one's saying nothing and other one's saying a ton, you're not getting any data that's useful there. So what do you do in that situation? Well, you have to look at trends. The American model we just looked at has been very bad 5 days out early in the summer. It's getting forecast wrong. That's in the back of my head. So out of the gate, I'm going to doubt that one, and I'm going to go with the drier one. Secondly, and weather late in the day, so, you know, here's the truth. Anyone can do weather on TV. If you're a good communicator, you don't have to have a science background or meteorology background. You can present on TV. That's key. Where you get your skill set in, and really kind of the meteorologist aspect is it's our job to do pattern recognition. Let's beat the models. I can tell you that throughout the last couple months, at least the last 2 months, the models, when they've been showing rain, have been days out showing too much, and when it ends up comes being drier. So that's going to be in the back of my head. So I'll see a forecast from one that'll say a lot of rain that hasn't been doing good forecast. I'll go, I don't know if I'm buying that. And then secondly, let's say I'm going to buy the rain. Let's say it was saying an inch. I'd cut it down to probably 0.6 of an inch. I would cut the numbers down, just flat out based on that's been what the trend has been. And there's a saying in meteorology, the trend is the trend. And sure enough, it looks like this is really kind of drawing things out. So this model, if you look carefully, Pennsylvania's right here. This model doesn't even, so this one's kind of bringing up some of the remnants there a little bit. So what's funny is this one's now more wet than the other one we looked at, which is funny. I'm liking what this one shows. Big picture weather, speaking of things that usually play with the weather. This one makes sense to me weather-wise. That this cold front helps kick it out. But it sounds like we're gonna have some cloudy kind of on showers. It's Monday. I don't think it's particularly get any heavy rain. I think it's just gonna kind of be off and on rain all day Monday. So Monday will be, I guess Monday would be the day we're gonna get the remnants. But if you look, the remnants will kind of shear out. In other words, the dryer kind of eats them up before it gets here. So anyway, a little bit of a cloudy wet start to the work week would be the message there. That's all we need to say for TV purposes. We'll have some showers and it'll be cloudy as we start the week next. That's it.
Very cool. Some under the hood meteorology here.
Yeah, little meteorology 101. And listen, getting back to what I was saying, you guys can have the link to this map, and really that's all you need. You know what I'm doing. What I do and any other meteorologists do, we get the American model, we compare that to the European. If they both showed the same thing at the same time, we have high confidence. If they disagree, well, that's why we're here. We're here to supplement the computer, because otherwise the computer would be the average. The Canadian model used to be very good, but they updated it like a year or two ago, and it just, well, I was always such a big fan of our friends to the north. Excuse me, I'm starting to get all choked up here. Our friends to the north. And this model, I kind of almost stopped looking at it because it's not been great. This one is a lot more out of any of them. This one, look at this one. This one's really wet. It makes the rain stick around. I don't buy that. I don't buy this to sit over us for days. So anyway, that's the bigger picture of what we have, and then it's a little bit easier when it's closer to the event because we get a lot more maps at our disposal. For let's say a medium range, 5 days more, you basically get 3 maps to look at, and that's it. And yeah, it's gonna work. So hey, anything else on anyone's mind?
I have the last question, unless anybody else has a question.
Yeah.
And this is sort of a shout out to the Black Hole Radio crowd from WEEU. Is Pluto a planet?
It's my understanding it's not, right?
No.
Funny Lord.
I'll have to pass that along then. Well,
Elon, to answer that, Pluto is actually a dog.
Oh.
Very good.
fair enough. Well, I've learned a whole lot about how, not just our weather here on this planet works. The sun's weather affects us too. So.
Yeah, it's interesting. I don't know why they call that weather. I could see why. I think it's a misnomer. I don't know. I don't like calling that weather because to me, weather is what we have. I don't know if I call that stuff weather, but I get it. And, one last thing I'll leave you guys with, and this will be in what I send out for you guys. Let me just share my screen one more time, is you can watch these solar flares. So there's a website, and you can literally see what the sun's up to, and you can see what's going on. We'll watch this. This is going to be the last. It takes about a minute to load. And we can look here and we look for any little burst of energy coming out, and this is kind of pretty quiet. So we're seeing right there solar wind. We're seeing corona, whatever you want to call it. And there's not a bigger burst or anything. It's a little brighter. So that's kind of quiet there. We'll check in on this one. Let me see what data this is. I think this is kind of like looking at the Earth sun. Again, it's been very quiet, so there's not much going on. But I will tell you this. I've seen, even going back a couple years ago, you will see kind of these little bursts of white light kind of travel away from it when we're in a more active time period. And this stuff's kind of cool because this is real-time data. I think today is the 8th. I'd bet money on today being the 8th. I don't have a calendar yet. Let me see if I can. Yeah, it is the 8th. Yep. So this is, I think, a pretty cool website. Oops. I accidentally stopped sharing screens. I hate when I forget how to use Zoom all of a sudden. We're all getting used to this, right? So this is a pretty cool website, and it's worth checking out, especially in like 5 years from now when it'll be more active. And if you want to kind of learn a little bit more from NASA's perspective, it's neat. So I'll send that along too.
Well, thank you so much for all of these resources, all of your knowledge and expertise, and sort of how to navigate this this sort of stuff.
Yeah, it was fun talking. I appreciate you letting me have a nonstop conversation for 2 hours. I do it during weather, so it's no problem to do it longer. And I look forward to coming out to the farm and taking a look at the night sky sooner than later.
Love to have you. Nice meeting you.
Look forward. Nice to meet all you guys. Again, thank you both.
Yes, thanks for the
Yeah,
talk.
thank you.
Thank you.
Okay, good night, guys. I'm out of here.
Good
Thanks.
night.
Good night.
Night.
Good
And
night.
for the Berks Astronomy folks, I'm working with a cafe, actually in Lancaster County. It's right on the border. It's in Ephrata, Stonehouse Cafe. We're talking about doing like a full moon watch in the grass there, but we'll see what happens with that. We're sort of just throwing the idea around and throwing it around with the Lancaster and Chesmont community too, sort of sticking to restaurants that might be open at that time. And piggybacking along with them. Other events coming up, I know we have, of course, our Blue Moon coming up at the end of the month for Halloween, and other public outreach events. I'm not sure if we have the one scheduled for the end of October, but I did hear back from Daniel Boone, and they're interested in scheduling for the spring. So stay tuned for that as well. Any other announcements or anything?
Yeah, I'll get you the information on that Star Watch at Cuckooing Meadows. I forgot to send it out to you on the Friday the 23rd.
Okay.
I mentioned it to you at the Star Watch because I won't be able to be there.
Okay.
Because they were doing a lunar talk and then, looking at the moon and planets, whatever.
As for the upcoming
That's
Blue
first. That's first. It's Spring Township Star Watch on Friday the 23rd with the rain date of the 24th. It's at Cuckooing Meadows, but at the State Hill entrance, and it's like a block or so away from the water treatment plant on State Hill Road. And I was by there the other day, and it's a nice flat parking lot and some grassy areas around it to set up telescopes, whatever. But it's the group is limited to 25 and they have to pre-register. So I think that's full right now, but.
As for the upcoming Blue Moon, which is Halloween night,
Yes.
we are planning here at the winery an event that hasn't been advertised yet. It will be wine and chocolate, and we're hoping to show folks the moon and the planet. Mars, of course, is going to be visible, and there'll be a band here playing, and there'll even be axe throwing for Halloween. So if anyone, maybe Alon, maybe you would like to volunteer being a target, we can use volunteers for that.
Get the
So we'll have axe throwing and chocolate and wine.
Oh, sounds perfect.
Under the moon for Halloween. So please look on the website and look for some advertisements coming.
Very cool. Do
It's
you know
also
what,
the next launch of astronauts to the space station is Halloween night.
Yeah.
Really?
That's
Wow.
a busy night.
But I think it's like 2:00 in the morning or something. I think I saw. It'll be a long night.
Yeah. Other space news. It was like Scrubtober to begin with, and then there were 3 rocket launches scheduled. I think 2 took off, and I saw the what was it? Antares launch from Wallops Island, Virginia, last Friday night from Fleetwood. So that was something cool to see. And since we're seeing more scheduled launches for the future of the Mars facility, we'll have to have some launch watches eventually from right here.
I went up to Shiloh Hills and I could see it less than a minute after launch there.
Oh, that is awesome.
Very awesome.
In fact, there's going to be more launches there because a New Zealand company is now going to be using it to launch satellites for U.S. customers.
I'm so excited. Rocket Lab might start launching before the end of this year from the U.S. facility. I think they have a launch scheduled net October 21st. I think they're looking at October 20th, 21st, and then scheduling it.
Are there any places near Wallops Island where the public could view a launch that you could get close enough to actually see the launch?
Anywhere along the beach.
Okay.
So anywhere along that beach. I know watch it from New Jersey, they watch it from Delaware. We should be able to find a spot.
Okay.
Very awesome. Any other space news anyone wants to share? I know, of course, the life in Venus's clouds is up for grabs. Phosphine is not. It's
not life. It's on Earth. It can only be produced by life, but they don't know that that is being produced by life. We don't know all the conditions that can cause phosphine to be produced.
Reason for the quantities that we're seeing it there. Also, salt water under Mars's surface. I think we knew about that a little while back, like 2014 or something like that. Liquid water, very salty liquid water, but I think we've narrowed a few locations of that recently. A few more, what's the word, Artemis contracts have been pushed around. Now we're looking at 2 companies going down to the surface. We'll see if it gets narrowed down to 1, but much more on the Artemis program and things like that to come.
I think Mars has to harbor some sort of organic materials under the surface. There's some sort of life forms there.
We have extremophiles on Earth that live in thermal areas,
yes,
in icy environments, so something's possible.
Can you hear me?
Yes.
Yes.
I was new to this, so I don't know when it's on. I haven't been in touch, but did anybody watch to see the International Space Station go over the Reading area? I saw it like 3 times. I just wondered what was happening with the rest of the group.
I saw it tonight right before we went on air.
Oh, really? Ah.
Yeah, there's a website, Heavens-Above.
Oh.
And you can plug in, just pull up Reading, and it'll tell you when and where the space station will go by. And also other satellites.
So it goes by a lot of times then? You can
Yeah.
see a lot
Sometimes you can see it 3 or 4 times a night.
Like it went over my house the first time I saw it, and they were telling me.
Every 90 minutes going around. So it all depends on how high in the sky we can see it. Sometimes it's below our horizon. We have some gaps in between some of the crossing paths from it. But heavens-above.com is an excellent resource. Also, if you have a smartphone, Heavens Above is an excellent app. It actually, if you type in your location or if you just name the city, it'll give you a notification right
That's only on Android phones. They don't have an Apple app yet.
I did it on app. I just Googled the, International Space Station, and then you can find a link, and it said, ask my address, my whatever, my zip code, my city, whatever it was. And then,
NASA does it too.
Mary, do you have a good?
How come that looks like it's like really like a plane in the sky when it's up 60 miles or however high?
It's 250 miles.
Well, how can it look? It looked like it was just like a plane flying over my area here. That it was so bright and so clear that night, and then
it has big solar panels and it's sun reflecting off of it. It's the thing bigger than a football field, and it's sunlight reflecting off of it.
If you have a good pair of binoculars, Mary, you can actually see structure. It'll actually look like not just like a white blob.
I had a pair. I couldn't. I did better with my eyes. I tried in my telescope. I gave up. I'm going to throw it out.
It's hard in a telescope. You can't track it. It moves too fast to really follow it in the telescope.
I don't know what's wrong with my binoculars. I'll have to join you when I get to see you. You can help me, teach me better.
Absolutely. Hannah, did you have something you wanted to add?
ISS Spotter is the app I use on my Apple.
Very cool.
And it points right to where it's coming up. It's a little off sometimes, but it even shows you where it's coming up and where it's going down, what time it's coming up, what time it's going down. It's good.
What did you say? Spotter? SP?
ISS Space Spotter.
Oh, okay.
And it's free.
Right. I think I did that. I think it came up. Because it says it'll be in your area from, like this time to that time. And then from the west to northwest to the.
Yeah, it shows you all that.
Yeah.
Very
Okay.
cool.
Thank you.
Right. So also I wanted to add a couple things that Angelo had passed along. He had, pointed out a few things obvious in our October skies. So definitely just check out, what's in your planisphere, what's on your observing catalog. October looks like a great month. Possibilities for the northern lights, of course, we just talked about that. A second alignment plane of the solar system, there were a few articles talking about that, and this is coming off of phys.org at phys.org with a lot of great articles here. Meteoroids skipping off the atmosphere. If it wasn't for Jupiter, Venus might be habitable. Some other articles from phys.org, from CNET, How to Watch Mars. Of course, we're seeing Mars move to opposition, basically a full Mars. Things like that, and some deals from Orion telescopes and binoculars. So we'll see what else happens, but feel free to share space news any or all the time. I mean, it's tough to share on the website. I know there's something, there's a way to do it, but I'm not sure. But the Facebook page is an easy way to share any of this space news. So I tend to post stuff at Berks Astronomy's Facebook page. It's just Berks Astronomy. Or if you look up Berks County Amateur Astronomical Society, it should pop up as well.
Hey, Alon, did you get your telescopes yet?
They are on the way.
Oh, yeah, I heard that too.
So, might be bucks down the drain, might be two 12-inch Dobsonians arriving from an international exporter. So we'll see what happens. I'll keep you updated. But right now,
I think it's got to be a farce. $10? I don't think so. But I did it.
We'll see. But fun stuff. That, and hopefully we avoid some of these cloudy blankets so we can see some clear stuff. So dig it out, dust it off. If you're going observing, hit me up, throw me a line, and I'm working on getting permission to set up in different parking lots and things like that in small groups for the club. So we'll see where that goes. But if you have any preferred spots, send me a message with them included. Send me an email with any preferred spots where we can sort of congregate in a safe and responsible way and take a look at
Tucson, Arizona observatories.
Berks County. All right. Anything else anyone wants to add?
Oh, the calendars came in. I got the calendars today.
Oh, okay.
I will contact you, Linda, to drop those off for you, some of those off for you, and those that are going to get mailed, and then those I'll make arrangements to either meet somebody somewhere or people can pick them up or whatever.
Okay.
So I'll send out an email. I didn't think about it before I sent out the email this morning.
Okay, they're keeping good time. Didn't take all this time.
All right.
If you can copy and paste this $6, Barbara, I can pay for one. I got the 50 cents too.
Use Zelle or Zelly.
What's that, Hannah?
Use, I don't know if you say Zelle or Zelly. You can send money easy with that.
Yeah, Wells Fargo, but we'll figure it out. If you're needing a calendar, just shoot an email around. We'll make sure it gets to whoever.
Yeah, Linda can order them or order more.
I can always order more as long as they have the supplies last. Last year, they told me they sold out in November already.
Oh, wow. Yeah, we'll
So,
stay tuned
right.
for the calendars.
So-
Roll that out in an email. So keep your eyes peeled. Anything
Yeah,
else?
because the calendars I have are already spoken for.
Yeah.
Email Linda then?
Yes. If you didn't order a calendar, Linda can order more.
So we
Okay.
pick it up at Linda's if we don't see you at a meeting or something, or a
Well,
store?
right now I have them. So I can, if you ordered one, we can either mail it. If we mail it, it's an extra $5 because we have to pay for shipping and stuff.
Send an
But
email.
or we can meet you somewhere or
I'll pick mine up at Linda's house, right? Or at a Stargate thing, Star Watch thing.
where are you coming? What area do you live in?
I'm in Exeter, near the Reading,
Okay.
like off of 422, only a mile off of 422. Exeter,
Okay.
I'm like near the Giant store, where Boscov's East is.
Okay, yeah.
I'll pick it up wherever somebody has it.
Okay.
Okay.
It said if she's gonna pick up at my house, then Barb, I'll need an extra calendar.
Okay.
No, well, I thought you said somebody go to somebody.
They're at my house right now. They're at my
Oh,
house right
oh,
now.
I got people mixed up. I'll pick it
Yeah.
up at your
We'll
house.
pick your calendar.
Oh, okay.
Calendars
Okay, and
with
she'll pick it up at Barb's house.
the
Yeah.
calendar.
Okay.
Or at a
Look-
Star Watch or something.
Yep, look out for an email about the calendars.
Yes.
Dave, you had an event coming up. Do you know what band is going to be there?
No, I don't. They're going to be playing blues, I believe. That's
right.
all. That's all I know so far.
Okay, very cool. Well, we'll get through Spooktober soon enough. I'm sure it'll be cold, so bundle up and keep observing, dig it out, dust it off, even if it's just you. But feel free to shoot out an email anytime you're going observing. Shoot it out to me, shoot it out to the club. We'll see what we can do, and we'll keep looking up. But thanks everyone for joining. With that, we'll end.
It was a
here.
fun night.
Yeah. Thank you.
Good night.
Thank you. Good night.
Good night, everyone.
Good night.
Good night.
Good night.
See you again.